Hello. You're watching part two of a series, a two-part series. And in part one, we would have discussed why factoring quadratic expressions is such an important thing. And what we observed was by taking a quadratic function in standard form, trying to find the x-intercepts without factoring would require, right now anyway, finding vertex form, converting from standard to vertex form, and then applying inverses to solve, which is not difficult, but it is a lot of work. If I can take x squared minus 7x plus 10 and write it in its true factored form, then finding the solutions for the x-intercepts is really easy to do. So that's our incentive for factoring. Now let's talk about how to do it. First of all, I want to remind you about unfactoring, which is also often commonly known as foiling, which stands for first, outside, inside, and last. It's the order in which we multiply binomials. It's to make sure that we double distribute. I've always preferred double distribution. If you want to look at it, this seems like a stupid thing to do, but I'm going to take the x minus 5 and distribute it into the x minus 2. So x minus 5 times x, and x minus 5 times 2, negative 2. So then what I can do is distribute, first, outside, inside, last, done. And the last thing I do is I take those two terms that are like terms and add them together to get x squared minus 7x plus 10. Now what I need us to do is to reverse, oh, this did not go well. All right, we went there. We want to reverse that process. So if I look here at the bottom, x squared minus 7x plus 10, the very next thing I should have is a four-term expression where the negative 7x was broken up into negative 5x and negative 2x. Here's negative 5, negative 2. The next thing that I did was, well, it seemed like I took a common x factor from the first two terms. Here's x squared minus 5x, I take out the x, and here's 2x minus 10, I take out the negative 2. And I get the same expression on both sides. So what I'm going to do here is simulate that by basically grouping the first two and grouping the last two, and I'm going to look for common factors between x squared and 5x, which in this case is x, leaving me with x minus 5. Over here, I look at the negative 2x and the positive 10. If I took out a negative 2, then I would get a positive x minus 5, which is the same as this guy right here. If these two are the same, then you are factoring correctly. And I recognize that x minus 5 is the same number, so I factor the x minus 5 out, and I'm left with the x minus 2 leftovers. Just to see that again, if I were to FOIL this out, I would distribute the x into the x minus 1 and the 3 into the x minus 1. So I'm double distributing, and so it gives me x squared minus x plus 3x minus 3, collect like terms in the middle, and we now have a quadratic form. Let's reverse it. From the three-term trinomial, we are going to split up the middle term 2x into two terms. And then I could take a common factor, x squared minus x, I'm going to take out the x, 3x minus 3, I'm going to take out the 3, x minus 1 is now in common, so I take that out, and bring down the x and the plus 3 after we've factored out the x minus 1 from both terms. So now I've just reversed the process of foiling, and that is called factoring, because you take an expression that's a whole and turn it into the product of two factors. That these two factors multiplied together will give us the original expression. Now, a natural, curious person would ask the question, how am I supposed to know what to break 2x into? In this case, 2x was broken down into negative x plus 3x. Really, there's infinity ways you can make 2x. You could take 4x minus 2x is equal to 2x. You could take 1000x minus 998x, and that would equal 2x. So why choose these two specific numbers? And how am I supposed to know what those two numbers are? Well, for that, we're going to get into more of the why later, but I just wanted to show you the how. And what it does is it involves factoring the 6 and the 5. So we're going to take the 6, the c value, the last term, and put it here at the top of this x box is what I call it, or magic diamond. And we're going to take this 5 and put it here at the bottom. Now my objective is to think of two numbers to put into the question mark slot, where if I multiplied them, I get the top number, but if I added them, I would get the bottom number. 2 plus 3 equals 5. 2 times 3 equals 6. Therefore, my 5x is going to be broken up into a 2x and a 3x. Now, what I learned in the previous observations was I'm going to factor the first two, or no, I'm not going to factor the rest of this later. I'm just going to finish that Xbox game. So here again, I take the negative 6 and the -5, put the -6 up top, put the -5 down below. -6 times 1 equals -6, and -6 plus 1 equals -5. So the -5x is going to be broken up into x squared minus 6x plus x minus 6. I'm going to continue to let the other ones go without talking. I would suggest that at this point you can pause and make sure you understand how each of these middle terms was broken into two different terms by using this Xbox method. Now what that's done is it's created a situation where I have four-term expressions, and I can use factoring by grouping to complete that work. So in the first example I'm going to show over here on the right, we have x squared minus 12x, and we have negative 3x plus 36. So I'm going to take out the common factors of x here and get x minus 12. And here I'm going to take out the common factors. Notice I have a plus, a minus. There should always be a plus sign in the middle here. But I'm going to take out a -3, which gives me then plus a -3 is minus 3 times positive x minus 12. Once again, this binomial has to be the same as that binomial in order for this process to work. So I take out the x minus 12, and I'm left with the x minus 3. Done. So once again, I'll just quickly play through the rest of these. It's all the same process, and if you want to pause the screen, you can actually see how each of these was done using the exact same technique or approach I showed you in red over here. All right, that should be enough information for you to practice factoring certain kinds of trinomial quadratic expressions on your own. Now, we haven't talked about these two-termers or what to do there, which is actually sometimes easier. We haven't talked about these numbers or these kinds of quadratics where the coefficient on x squared is not 1. We're going to have to take care of that later, but for now, I would like you guys to practice just doing the 6 expressions that I've shown. See if you can get full factors for each of those 6. So the 3 that I circled up top and the 4 that I circled down in bottom, factor for the win. Have a good day. Thanks for listening.